In this video, we'll talk about the indeterminate forms and L'Hopital's rule, which is given in 5.6 from the book, section 5.6. Okay, so you remember that how did we find the limit of this function? Okay, to find out the limit of this function, the first thing we do is you plug in the limit directly, right? If you plug in the limit, what do you get? You get 1 square is 1 minus 1 over 1 minus 1. That will be 0 over 0. So if you get the form 0 over 0, we call indeterminate form. We don't know how much is that. Is that a big number or a small number? Is that 1? No, it is not 1. Okay. So we don't know how much that number. So we call that type of form is called indeterminate form. Okay. But how do I find out the limit of this type of function? In case of you get of this form, or infinity over infinity, sometimes you get that too. In that case, you try to simplify the top and bottom and find out the limit, right? So how do we do that? You write limit x tends to 1, and you can write that as x minus 1 times x plus 1, because it is like a squared minus b squared. If you get the factor, you'll get a plus b times a minus b. And what you do next is you cancel out the common factor, you divide, right? So what is left there is x plus 1. You see that? And then finally, when you plug in the limit, now after you get the lowest form, you plug in the limit, and then you get 1 plus 1, that is 2. So the limit is 2, meaning that when x tends to 1, the graph of this function has height almost 2. Okay, so this problem was not very bad because we were able to get the factors on the top, and then bottom was already in the factored form, and then you were able to cancel. But if you get an example like this, e to the x minus 1 over sine x, we cannot factorize like this here, right? And if you plug in the limit right away, you will get e to the 0 minus 1 over sine 0, right? You get 0 over 0. See why? Because e to the 0 is 1 minus 1. So 1 minus 1 is 0, right? Over sine 0 is 0. So you get 0 over 0. But how do I handle this type of problem? Because I cannot get factors here, right? So that is the problem. So to handle this type of problem, there is a rule we call L'Hopital's rule. Okay, we'll talk about that later. There is a very easy way. I mean, to do this problem too, you don't have to do the factorize. So you don't have to factor. So there is an easier method to do this problem too, to find out the limit. Okay. So let us talk about the indeterminate form. If a function takes a form 0 over 0 or infinity over infinity at a point, the point can be a finite number or at infinity. That can happen, okay? Then it is called indeterminate form. So either 0 over 0 or infinity over infinity. When you plug in the limit right away, if you get one of those form, then we call that as indeterminate form, okay? And then other type of indeterminate forms are infinity minus infinity, 0 times infinity, 1 to the infinity, 0 to the 0, and so on. So why they are the indeterminate form? Because these forms can be reduced to one of these forms. Okay. For example, this can be written as something like, you can think as like 1 over 0 minus 1 over 0, right? That will be basically kind of, you can think of 0 over 0, right? And here, this one can be considered as 0 times 1 over 0, right? So 0 times 1 is 0 over 0. So that gives you 0 over 0. So here, if you take natural log, you will get infinity and then natural log of 1. That will be 0 times infinity, or this is because this is 0, right? And 0 times infinity. Similarly, this one is 0 times infinity too. So since these forms can be reduced to one of these 0 over 0 or infinity over infinity form, these are also the indeterminate form. Let me clearly list the indeterminate form, okay? When you plug in the limit, if you get one of these forms, then we call indeterminate form. There are 7 of them. So one is 0 over 0 is indeterminate form. If you get infinity over infinity, that is also indeterminate form. If you get infinity minus infinity, that is also indeterminate form. Another one is 0 times infinity, that is also indeterminate form. 0 to the 0 is also indeterminate form. 1 to the infinity is also indeterminate form, and infinity to the 0 is also indeterminate form. So the very basic indeterminate form are the number 1 and 2. the all other indeterminate form can be reduced to one of these form. That's why these are also the indeterminate form. Okay, guys? Okay. Now, so when you plug in the limit directly, if you get one of the indeterminate form, how do we handle that type of problem is given by the L'Hopital's rule. Let's see what it says. If f and g are differentiable in AB containing C, suppose the interval AB contains a point C, and suppose f and g are differentiable everywhere in AB except it may not be differentiable at C. Also assume that the derivative at all the points in that interval is non-zero except possibly at C. So the function f and g must be differentiable everywhere in between A and B except at C, or it may be except at C, but it should be differentiable everywhere between A and B. And then also if the derivative of g is non-zero everywhere except at the point C, and if the limit x tends to C fx gx, if this limit, you see that, if this limit produce an indeterminate form 0 over 0 or infinity over infinity or any of these indeterminate form, then that limit x tends to C fx over gx can be written as limit x tends to C f prime of x over g prime of x. What does it say? It says that if you're trying to find out this limit, you can find out the derivative of the top directly and the derivative of the bottom directly, and then plug in that limit on the derivative. You don't have to do the quotient rule here. Just find out the derivative of the top and find out the derivative of the bottom. Okay? And then find the limit. So that limit is same as that limit. Okay? So provided that the limit on the right exists. If the limit on the right hand side is a finite number, that's the answer. If the limit on the right hand side still gets 0 over 0 or infinity over infinity or any of these indeterminate form, then you'll continue doing that. Okay? So one of the very important thing on the L'Hopital's rule is you need to have a function on the top and a function on the bottom. Otherwise you cannot use that form. Okay? You need to have a function on the top and then divided by another function on the bottom. And if you plug in the limit directly, if you'll get 0 over 0 or infinity over infinity or one of these form, then what you do is you try to find out the derivative of the top only separately and the derivative of the bottom separately and plug in the limit. If you get a finite number, that is the limit. If you don't get, and then you'll have to if you get 0 over 0 or infinity over infinity like indeterminate form again, then you'll have to continue. Okay, so the things will get clear once we do the example. Let us do the exactly same problem here. Okay, like the example that we discussed. So use the L'Hopital's rule to find out the limit of these functions. Okay, let's see that. Let us plug in the limit directly. You'll get 1 square is 1 minus 1 over 1 minus 1 is 0 over 0, which is the indeterminate form. The L'Hopital's rule, let me write down L'Hopital's rule. LR is the L'Hopital's rule, implies that in this case when you get 0 over 0 you can find out the, let me write the limit on the top, limit as it is, find out the derivative of the top. What is the derivative of the top? Is it 2x, right? 2x divided by the derivative of the bottom is just 1 because the derivative of 1 is 0, 1 is 0 there, right? Now plug in the limit. If you plug in the limit, do you get 0 over 0? No, you don't get 0 over 0 anymore. Now plug in the limit then. So 2 times 1 is 2, over 1 is just 2. That is the answer. So you don't have to do all these simplification. It is just easy, right? Find the derivative of the top separately, find the derivative of the bottom separately. Never make a mistake by doing the quotient rule here. You don't have to. Just find the derivative of the f, find the derivative of the g separately and plug in the limit. Let us do the second example that we were not able to do it, right? When you plug in the limit here, you get e to the 0 minus 1. E to the 0 is 1 minus 1 is 0 over sine 0 is 0. We got indeterminate form. So we are okay to use the L'Hopital's rule. Okay, we are okay to use the L'Hopital's rule. Okay, let's do that. So this function basically, both of the function, the top function is differentiable everywhere, the bottom function is differentiable everywhere. So you don't have to worry about the assumption there. And here also the top function is differentiable everywhere and the bottom function is differentiable everywhere. Okay, so we don't have to worry about that. Okay. So let's use the L'Hopital's rule equals to, let's use L'Hopital's rule. What you do is write down the limit. since it takes the form of 0 over 0, you can find the derivative of the top. What is the derivative of e to the x? E to the x itself minus 0, because minus derivative of 1 is 0, over what is the derivative of sine x? Is cosine of x. Now you plug in the limit. What do you get? E to the 0 is 1 over limit x tends 0 is cosine 0 is 1. So it is basically 1 over 1. So the answer is 1. See how easy it is. You don't have to factorize, you don't have to do anything. Just find the derivative of the top, derivative of the bottom. But you need to have one of these indeterminate form to use that L'Hopital's rule. 0 over 0 or infinity over infinity. Okay, that is the main. And other indeterminate form can be changed into one of these. So they are also okay.